5G networks are the latest and fifth generation of mobile wireless networks. They are designed to be faster, more efficient, and more reliable than the previous generations of wireless networks such as 4G, 3G, and 2G. The main benefits of 5G networks are 1. Speed. 5G networks can provide download speeds of up to 20 gigabits per second, GBPs, and upload speeds of up to 10 gigabits per second, which is much faster than the current 4G networks. 2. Low latency. Latency refers to the delay between sending a request and receiving a response. 2. With 5G, latency is expected to be reduced to less than 1 millisecond, which is much lower than the 10 to 20 milliseconds typically seen with 4G networks. 2. This will enable applications such as virtual reality, gaming, and real-time video streaming to work more smoothly. 3. Increased bandwidth. 5G networks will be able to support more devices and more data-intensive applications due to increased bandwidth. 3. This means that more people will be able to use high-bandwidth applications simultaneously without experiencing delays or lag. 4. Improved connectivity. 5G networks will use a combination of different frequency bands, including both high and low frequencies, to improve connectivity in both urban and rural areas. 5. Enhanced network slicing. 5G networks will allow network operators to divide their networks into different virtual slices, with different characteristics, such as speed, latency, and reliability. 5. This will enable them to offer customized services for specific applications and use cases. Overall, 5G networks are expected to transform the way we communicate, work, and live by enabling faster and more reliable connections for a wide range of devices and applications. Here are some additional details on 5G networks. 1. How does 5G work? 5G networks use a combination of different technologies, such as millimeter wave, wave, sub-6 GHz spectrum, and massive MIMO, multiple input, multiple output, to deliver faster and more reliable connections. Wave uses high-frequency radio waves that can carry large amounts of data over short distances, while sub-6 GHz spectrum can travel longer distances but with less capacity. Massive MIMO uses multiple antennas to transmit and receive signals, which can increase the capacity and speed of the network. 1. What are the applications of 5G? 5G networks have a wide range of potential applications, including 1. Enhanced mobile broadband, EMBB, for faster internet browsing, video streaming, and online gaming. 2. Ultra-reliable low-latency communication, URLLC, for applications that require real-time responses, such as autonomous vehicles, remote surgery, and industrial automation. 3. Massive Machine-Type Communication, MMTC, for connecting large numbers of devices, such as smart homes, smart cities, and the Internet of Things, IoT. 1. What are the challenges of 5G? There are several challenges associated with 5G networks, such as 1. Infrastructure. Building 5G networks requires a significant investment in infrastructure, such as new cell towers and fiber optic cables. 2. Spectrum. The availability of spectrum is a key factor in the performance of 5G networks, and some countries are still in the process of allocating spectrum for 5G. 3. Compatibility. Older devices may not be compatible with 5G networks, which could create a digital divide between those who can access 5G and those who cannot. 4. Security. 5G networks are expected to be more vulnerable to cyber attacks than previous generations of wireless networks, due to their increased complexity and reliance on software. 1. What is the status of 5G deployment? 5G networks are being deployed around the world, with some countries such as South Korea and China leading the way in terms of coverage and adoption. However, deployment is still in the early stages in many other countries, and it may take several years before 5G networks are widely available and affordable for consumers.